Well, on behalf of the organizing committee, welcome to the workshop on integrated modeling for adaptive management of estuarine systems. My name's Peter Goodwin. I have the honor of serving as the lead scientist for the Delta Science program. First of all, we'd just like to recognize the many people that have made this happen. In particular, we would like to recognize the sponsors, the Delta Ship Stewardship Council, and the National Science Foundation for providing the support for this meeting to happen. We'd also like to recognize our co-sponsors, the California Water and Environmental Modeling Forum, the International Association for Hydroscience Research and Engineering, the International Environmental Modeling and Software Society, and of course the USGS. And also we'd like to thank UC Davis and in particular the Center for Watershed Sciences for hosting the meeting. A lot of effort's gone into making this happen. We'd like to acknowledge the planning committee. They're listed on the back of the program. And they're listed here as well. In addition to that, we'd like to acknowledge the many folks who are here from other large-scale ecosystem management programs in the US, from the Great Lakes, Puget Sound, Everglades, Chesapeake Bay, Columbia River Basin, amongst others. And we'd like to extend a particularly warm welcome to folks who've traveled internationally to participate in this workshop from the European Union, KICT in Korea, from Hong Kong, and from Australia. So the question is, why are we all here? And looking at it from the national level, a few years ago, Tim Colleen, who at that time was at the National Science Foundation, defined the ultimate sustainability challenge. How do we maintain and improve the quality of life for the Earth, for the nation within a healthy Earth system? And in California, we have an equivalency to that, which is referred to as the co-equal goals. This is actually set in state statute. And this says that when the state of California undertakes activities associated with the Bay Delta estuary system, that can only be done if the two goals of providing more reliable water supply for California and protecting and enhancing the ecosystem is addressed. And in particular, that has to be conducted in a way that maintains Delta as place. So this is a very unique part of legislation. But from those of you from outside California and are working on modeling socio-environmental systems, this is truly the poster child. And here in California, as you'll hear from some of the latest speakers, just the magnitude of the problem. So California's grand challenge in National Academy's term can be defined by these trying to meet the co-equal goals. More than 2/3 of California residents rely on water that's pulled from the Delta. That water also irrigates up to 4 million acres of California farmland. That's on the water supply side. On the other side, just pulling a few facts out, there are over 700 species that rely on the Delta, and more than 50 of those are either threatened or endangered. So this makes it a hotspot for biodiversity globally, but it's also a location where we are experiencing the greatest loss of biodiversity. And this system is incredibly at risk. Without going into those details, an earthquake in the wrong place in the Delta could cut off that water supply in very short order. Also, for those of you who are following the press, we're currently in the 4th year of an extremely severe drought. So this is the California perspective, but the idea behind this workshop is to look beyond that by reaching out, seeing what else is happening both in the US and overseas. We want to ensure that the outcomes of your work over the next 2 days gets applicability beyond California, but we want to use California to focus discussions. So why California, and why are we optimistic that California can solve this challenge? Again, here's just a few facts about California. According to a recent survey that was done by the Chinese government, California has 6 of the top 20 universities in the world. And that's really reflected when you work here for a little while. What this means is that people who are working in agencies come from those elite universities, or they've outcompeted people from those universities to obtain the position. So there's a very highly qualified workforce here. And that's true whether you're looking at water agencies, local government, NGO staff, federal agencies, state agencies, as well as the universities themselves. Secondly, of course, California is the global center for information technology and cyber infrastructure. The Palantirs, the Googles were all hatched right here in California. The rate of sensor technologies from places like Stanford and Berkeley and UCLA is quite remarkable. And there's also this ethic about environmental stewardship. Some of the most advanced environmental laws in the world are based right here in California. And most importantly, California truly understands the value of science and good science. And as an example, just 2 recent quotations, there was a joint statement issued by Governor Brown and the President Obama's administration in 2012 that to solve these really tough problems in California, the science would be used as a guide. And it's also laid out in state statute. The California Water Code says that in carrying out the activities that are tasked by the Delta Stewardship Council, they must make use of best available science. So without going into the definitions and some of the challenges of doing that, there's just a very solid base. A few of the plans which are going into this, the California Water Action Plan, that Gary Bardini here is tasked with overseeing a big portion of that. There's the California Water Plan of the Department of Water Resources, particularly focused on the estuary that we're going to be talking about in this workshop. There is the Delta Plan that the state legislature and the law had tasked the Delta Stewardship Council to develop. And within the Delta Plan, there's the Delta Science Plan. In the Delta Science Plan, that was a remarkable document. There was well over 1,300 individual contributions to this plan, and it was an expression both of the science communities, the managers that use that science, and the agency directors that are tasked with these enormous decisions. This science plan looks at 2 things. One is how do we do science, and the second is the infrastructure that's required. For the infrastructure, last year we hosted a summit on big data, big environmental data. And the second one that was called for in the science plan is, in fact, this workshop. Some other things about what's special about California, the use of conceptual models when you're dealing with these immensely complex issues. The science community is very good at starting out and laying out the overall picture. And here's just one example of an early conceptual model. And of course, the legacy through the California Water and Environmental Forum that pulls together many of the hydrodynamic water quality models is quite remarkable. And of course, there's a long legacy. Hugo Fisher in the top left-hand corner there, the great late Professor Ray Crone in the bottom left-hand corner. So there's a long history here about the modeling. So what's the problem if we're doing so well? The recent NRC report in 2012 pointed out that there's world-class science going on. This is one of the most studied estuary systems in the world. And what they said is that much of the research that is done is absolutely world-class, but it's focused around individual agency missions or program activities. And what's almost entirely lacking is our ability to look from a systems perspective and understand the cascade of consequences. Marina Brand, who's here from the science program, a few years ago, she did a survey. There are 29 at that time adaptive management programs that have some sort of influence on the Bay Delta, and they all interact. We've made some great strides. You'll be hearing about the cascade model of the USGS, very innovative in going right from global climate models down to individual species response. The work that Steve Linley's team is doing on life cycle salmon modeling, the work of Ken Newman of the smelt life cycle models, this is really world-class research. But these models, as sophisticated as they are, do they really have the best streams of knowledge and information to feed into them from the discipline-specific experts? And I'll allow them to talk about it. Also, how do we quantify uncertainty in these incredibly complex systems? And how do we assimilate real-time data to get information turned around quickly to those people that have to make these enormous decisions? And so, in this workshop, we really want to think about innovative, to be bold and to be innovative. How do we create these sorts of models in such a way that we have an open and interactive science community? We can get the best people to the table, and we can begin to understand and unravel some of the complexities of this incredibly dynamic and open system. A few things that this is not. We're not advocating a single model or suite of models. In our opinion, this stifles innovation and understanding. We're not suggesting diminishing in-house capability of agencies. This is critically important. And we're not suggesting diminishing the role of the private sector or the academic session. What we're really interested in is how can we build and foster a much more dynamic system. And as one modeling community, and just as one example, a few of us went up to the celebration of the Snake River Plain water adjudication. Over 157,000 water claims were adjudicated in this process. And we asked the question, the judge was relying on a model. How many times in that 157,000 claims was the modeling challenged? And the answer was not once. Why? Because they had got together at the beginning of the process, brought all parties together. The model certainly isn't perfect, but people trusted it and understood its limitations and how it should be developed in the future. So our challenge here is what's possible. Here is, you'll perhaps recognize many of these images here. This is what other parts of the US is doing in terms of creating the types of physical and distributed centers that builds community modeling. And the question is here, should we have a facility like that? What sort of technologies could be brought together? How should we organize ourselves to truly make this a fully functioning modeling community? How do we develop the open and shared models of tomorrow while supporting the models of today? How do we train the next generation of modelers to be able to work in this era of big data and community modeling? And perhaps most importantly, how do we support and sustain an effort? So we feel that this is the time, as you're going to hear, whether you're in DC, whether you're here in California, right from the top of agencies and from the community models, there's this feeling that we need a new way of doing business. So thank you for your attention there.